class follows the same structure. It starts with a daily summary, which is just a sentence or two about what we're going to be talking about in class, followed by a demo, which I will stand at the front of the board, do some stuff, traditional lecture, followed by answers to the demo, just in case you missed class. You could do it on your own. The answers are there. Followed by activities. Okay, this is going to be the bulk of class, right? You'll be working individually or with your groups on these activities. The answers are right after the activities, so you can check your work as you go. And if you can't get your answer to match the answer in the answer key, you call me over or you ask a neighbor. And following those answers is one more section called Even More Practice, which is always optional. Okay. This is meant for if you want some extra practice when you're studying, or if you just found a lesson particularly difficult and you think, I really should do some extra practice problems on this lesson, you can do these. Or if you finish the activities super fast in class, you can move on to the Even More Practice. But it is optional. And it is also followed by solutions or answers. So then there's an answer key for that. And then the very last thing is the learning objectives. Learning objectives after lesson 3. This is today's. There's a list of things you should be able to do. So you should be able to read through this list and say like, oh yeah, I know how to use equations to solve problems. Or, yep, in my homework, I created equations that represented problem scenarios. Like, these things should sound familiar. Then there's a reading assignment and a homework assignment. So everything you need to do is listed at the very end of each lesson. Right here. Oh, it's in the textbook. In the textbook. Read section 1.5 of your textbook, which you could read from an actual book or the online version of your textbook. So when you're in my math lab, I go to chapter contents, and when that pops up, there's an option to open the table of contents, and a new window opens with your textbook. Except I need to update Adobe Flash on this computer. No, like the library, they said the same thing. Thank you. I will make a note to myself to submit an IT help desk ticket to have all the library computers updated so that it'll work. Thanks. Okay, so that's the general structure of class. So let's go back to the start of lesson number 3. Linear models. All right, so in this lesson, we're going to be solving word problems that involve linear equations, and we're going to graph lines using intercepts. We're also going to learn how to identify dependent and independent variables, as well as how to write an equation for one variable in terms of another. So it's a lot of stuff. Those are all the things we're going to do today. Okay, so a model is a mathematical description of a real-world situation. Okay, so suppose an individual works X hours at a salary of $7.50 per hour. And I'm going to fill in this table that shows how much they make for various numbers of hours worked. Okay, so if they worked 0 hours, how much money do they make? $0. 1 hour, how much money? $7.50. How about if they work 4 hours? $30. How'd you figure that out? $7.50 times 4 hours, $30. How about 6 hours? $45. And 10 hours? $75. Good. Okay, so for each increase of 1 hour, so each additional hour you work, how much more money do you make? $7.50. Okay, so that hourly rate, does it change or does it stay constant? Is it always $7.50? Yeah, Yeah, your hourly rate stays the same. So that stays constant. Okay. Unless you're a lucky person who gets to make time and a half or double time, right? But generally stays constant. Okay, so for each additional hour worked, there is always an increase of $7.50. This is an example of a constant rate of change. And the constant rate of change between two variables x, between two variables, is what distinguishes a linear model from another type of model. Okay. So it's that constant 1 unit increase in x, number of hours worked, always leads to the same increase in y, wages earned. Okay. All right, so if I wanted to write an equation for w in terms of x, that means I want to write an equation that looks like w equals some stuff with x's in it. That's what w in terms of x means. 7.5x. So there's my equation. Wages is equal to $7.50 per hour times the number of hours. All right, I'm going to plot my points that we came up with earlier. I've got 0, 0. 1, 750 there. 4, 30. 6, 45, and 10, 75. And you'll notice they fall in a straight line. So I can connect them. Preferably I'd use a straight edge, but I don't have one. So the reason they all fall in a straight line is because for each hour worked additionally, you make an extra $7.50. That constant rate of change is what makes it a line. That's why we call it a linear model. Okay, because our wages depend on the number of hours that we work, we call W, which stands for wages, the dependent variable, right? How much your paycheck is going to be for depends on how many hours you worked. So we call X, which is the number of hours you worked, the independent variable. If it helps you to remember which one is the dependent and which one is the independent, think of Johnny Depp on an island by himself in Pirates of the Caribbean. So the dependent variable, dependent, right, is the one by itself in the equation, right? So if W equals 750x, which variable is by itself on an island? W, dependent variable. Ian is great at making these things up. Okay, so of these two equations, if we have R is T divided by 121, or T is 121 times R, which one of those expresses T in terms of R? It's the second one. Yeah. T in terms of R means T equals stuff with R's in it. So that's the T equals 121R. That's T in terms of R. Okay. And if we look at that equation, T equals 121R, which letter is by itself? T. Okay, so T is by itself on the island. So T is the which variable? Independent. Dependent. Dep, right? Dependent. So T is by itself on an island. It is the dependent variable. Okay. And R, my other variable, is the independent variable. Okay, so we're going to learn how to graph a line besides just by plotting points. Okay, so we graphed a line by just getting a bunch of points and plotting them. They'll fall in a line, you connect them. Here's a quicker way to come up with a line. You actually only need 2 points to draw a line, right? Any 2 points determines a unique line. So I'm going to pick 2 very special points. One where x is 0 and one where y is 0. Okay? Because it's really easy to plug 0 into stuff because 0 times anything is 0, right? So 0 is a really easy number to work with. So the 2 points I come up with, one's going to have x be 0 and one's going to have y be 0. Okay, so in the first row of this table, I put a 0 in for x, and I need to figure out what y is going to be. Okay. So I'm going to plug x equals 0 into this equation. So that would be 3 times 0 plus 2y equals 12. But what is 3 times 0? 0. So that whole term just goes away, right? Because 0 plus 2y is just 2y. And so y has to be 6. Good. And then I do the same thing, but this time I'm going to make the y 0. Okay. So let's see, I wrote it down here. If I make y 0, I have 3x plus 2 times 0 equals 12. But 2 times 0 is just 0. So I can just cover that term up because 3 plus 0 is, or 3x plus 0 is still just 3x. So 3x equals 12, x would have to be 4. So I put a 4 here. When y is 0, x has to be 4. So my points are 0, 6, and 4, 0. Okay, so I can plot those 2 points. 0, 6 means I don't go left or right at all, and I go up 6. And 4, 0 means right 4, no up and down, and then I connect those 2 points with a straight line. Not the straightest line. Oh well. So this method of graphing a line, making x 0 and figuring out y, and making y 0 and figuring out x, is called the intercept method of graphing a line. And the reason it's named that is because the point 0, 6 has an x-coordinate of 0. It lies on the y-axis, and the point that lies on the y-axis of the line is called the y-intercept. Right? And 4, 0 is the x-intercept. It's where it intercepts the x-axis. This line intercepts the y-axis at 6 and the x-axis at 4. So that's why we call it the intercept method. Does that make sense? Questions? Okay, so if you missed anything, the answers are all written here. And then as we go to the next page, that's where the activities start. So I'm going to stop the video, I'm going to stop talking, and you're going to work either individually or in your groups, however you're comfortable, through the activities.